All right, this is part two. This video was cut off, so let me just move on with it and show you. We're doing a problem that says calculate acceleration of the box sliding down, and I had left off with this part in the end of the video. The net force is Fx plus the friction, and the net force will equal 16, and 16 is your Fx. Okay, it's the component of gravity pulling you down. Okay, the box doesn't fall straight down 9.81, but instead it gets pulled at this force. And we also mentioned that the person that says it was sliding it down, really, we'll say they were guiding it down. They weren't really pushing or pulling it all. They don't have any effect on it really at all, because it didn't give you a number, and also because gravity force, the component of gravity, is pulling at 16 newtons on this box, but friction is only 5.2 newtons negative. So that means it's going to obviously have a net force on it. So the net force will equal 16 minus 5, 11 newtons. Now, also, since we know the net force, let me get rid of this. It's a different problem completely down here. Sorry about that if that confused you. Okay. Actually just had a class. You might have been in the class while I told you how the video was cut off. Net force is always ma. That's how you can find the acceleration. So if the net force is 11 newtons, the mass is 2 kilograms, then you can calculate the acceleration here, and I don't even need a calculator for that. Divide by 2, 11 divided by 2 is 5.5 meter per second squared is the acceleration. So that's all that we had to put on there. Now, on the worksheet, there are some problems like this, and I will highly recommend that you start off with an equation like that. The net force on the box will be Fx, the gravity component, will always be pulling it down in this direction. Friction will be going in that direction. Now, what can change on some of the problems? Well, let me tell you about friction. No, let me take that back. Fx is the only one that will always be going down, if you want to call that negative. Oh no, I let friction be negative. Sorry, I let down be positive here. Fx will be negative, okay? But what you should know, let me start over again, because I'm going to confuse even myself from saying this so many times. Where's the eraser? I just erased something, didn't I? Go back and watch the video and see where I put the eraser. Oh my goodness. Crazy Vela. Where did you put the eraser? I can't erase anything right now. This is amazing. Wait, is it underneath? There's a chair here. Oh, nope, it's not there. I've got a chair. I've got my notes. I've got a... Oh, wow. Okay, I see what happened. It must have fallen. It fell back behind the computer. I don't feel so goofy. Like I'm looking for the eraser and it was in my hand or something. Okay, so when you're doing a problem with an inclined plane and friction's going on, remember friction is always opposite direction of motion. You can always take an equation starting off with this. The net force is Fx. Or if you want to call it Fgx or F weight x, whatever you want to call it. But it's the Fx of the weight, whatever the weight is, Fx. That one will always be pulling you down this way. So if you want to let that be positive direction, okay, then that will be negative direction. Now, friction will always go opposite direction of motion. So if somebody were pushing it up the ramp, then they would be pushing it that way, but friction would be actually acting that way. If they were pushing it down, then or if we're sliding down, it's going that way, and friction's going that way. One more thing I'll add is that if it's moving down at a constant speed, if it says, okay, this box is sliding down at a constant speed, what that means is, it means that the friction would be the same as Fx. Well, let's think about that for a minute. If it's moving at a constant speed, the net force would have to be 0. So if it were just the same situation moving down, so Fx plus the friction, and of course you put in that Fx is positive and that F friction is negative, then those two numbers will be equal to each other but opposite. One's positive, one negative. Okay? Now if you had another force in there, like a person was pushing it, well then now you got to add that factor in too. And you got to figure it out. But the key is constant speed means net force equals 0. F net equals 0. If it's accelerating, and that's when I showed you before a moment ago, then it's not going to be 0. It'll be ma, and you'll find out what that acceleration is. And you can put it this way. Put ma. I could have done my whole problem a moment ago, plugging in the mass, and finding a. Or I could just say, well, let me find the net force. Now that I know net force, I'll plug that in for F, and then I'll solve for A here. I could take it like 2 steps, as I did a moment ago. So there's a lot to work on for this assignment. So you only need to do number 1, 2, and 3. And we'll probably have a lesson, and then I'll maybe go over it in class, and then I might have you do some more problems after it. Because this gets to be like one of the more difficult levels, and we kind of already hit enough for that. I'll see you guys. All right.